So my name is Serge Maginot. I'm the CEO of Tiempo Secure. I'm here to introduce a first secure RISC-V common criteria certified root of trust or security enclave or secure element, whatever. So who are we? Who is Tiempo Secure? We are a European IP provider specialized in security. We have 14 years of experience in developing secure IP and secure embedded software. Our R&D center is based in France and is audited and certified by the ANSI. We have our own patented technology and innovation capabilities to develop any secure IC design for various applications, automotive, IoT, smart card, mobile. We have a unique expertise, the team has a unique expertise in secure IP design and services, from delivering secure IP to SoC manufacturer, as well as providing services like secure key provisioning, HSM server setup for key management, for example. And last but not least, and this is our main differentiator, we are the only security IP provider that contractually commits to our customers to pass high-level security certification, such as the CCEL5 Plus or EL6 Plus certification. Okay, what do we offer? We offer a broad portfolio of high-end certified IP and services for secure IC design and production. Okay, our flagship product is an integrated secure element IP. I mean, the full security enclave, the one we have been announced last week for the show, is a secure enclave based on a RISC-V architecture. We historically had our own proprietary CPU, secure CPU. Now we deliver RISC-V based one, and we are also open to do custom secure element design for a customer for a legacy code. Okay. So what is a security enclave? It's a full secure subsystem. It includes a secure MCU, cryptographic accelerators, secure memories, as well as standard interfaces, and access to a secure NVM. I mean, typically an external flash chip, or an internal flash or MRAM or whatsoever NVM. This is what we deliver. Since last year, we also are open to open basically the box of our security enclave and to deliver specific IPs, still high-end IPs like TRNG, specific crypto processor accelerator, for our customers who already have the security enclave that they develop at their own. So like for the security enclave, like for TESIC, we specialize in high-end security. And to complement this IP offer, we provide a secure provisioning solution to our customers. You know that when you have a secure enclave, to protect your secrets and to execute your secure code, we need also, during the personalization process of the chip, inject keys, unique identifier, and encryption keys that are unique to the device. So we provide such solution in a way that is very flexible according to the customer needs. It can be the full programming of a HSM server that is placed in the test facilities of our customer during the production phase, or it can be an adaptation of our software to the provisioning solution that our customer already has. Okay. Together with these solutions, we provide specific services. Since 2 years now, we have companies OEMs coming to us and asking for a specific chip design, secure chip design, like SIM chips, chips for SIM authentication, or payment chips. This comes with the shortage, of the semiconductor industry right now. So in that case, you partner with a design house that is also having a booth here called IC Alps, to provide a full chip solution to our customers. We, Tiempo, we are still an IP provider. We specialize on IP. We do not do specific chip design. And last but not least, we provide certification as a service. Okay, so as I said before, Our main differentiator is when we provide an IP, the complete integrated secure element to our customer. We commit contractually to our customers that each chip is going to pass a common criteria EL5 plus certification, and we provide to our customer a service ensuring this certification. That means we develop the full documentation for certification, and we support the evaluation lab performing the security evaluation of the customer chip. So what is the security evolution and transformation that we observe, over the last decade? We come, historically, Tiempo, we come from the smart card domain. So it's really the first part, over the last 10 years, we developed chips for secure microcontroller for the smart card industry, either the SIM modules, payment cards, or ID documents. As you know, today, the connected world does not use these, SIM cards anymore. It's not practical. So they mostly use embedded SIM. I mean, a chip that is for good for once in the full system, and that can be configured by software. This is today's connected world, is to have this specific secure element chip, I would say, included in the system of the OEMs, particularly to ensure the connectivity authentication on the mobile network or the NB-IoT network and so on. We, Tiempo, are working on the future already with the integrated secure element. The secure element is no longer a specific chip, but will be integrated in the any SoC, even an application processor chip. It's really in the heart of your system, inside the chip itself, where we provide this integrated secure element. Okay? It has many advantages. I will go over that on the next slides, but it means that really the integration is going one step further. It's no longer one chip for one secure element, but one secure element, sometimes even more than one secure element inside every chip. What are the added value of integrated secure elements? Of course, it's a better integration, both in terms of area and power, that are especially important in the embedded world, It allows also a tightly coupled interaction with the rest of the device, with the SoC, with the application processor. It provides for more flexibility, because basically the customer SoC, system on chip, application processor, can be personalized later on in the production process using software, and can be activated later on. Security integration is more convenient from that point of view. Then, of course, actually it should have been the number one criteria, but it provides higher security. We can provide solutions for fast and secure upload of secure services inside the secure element. And it's also a cost-effective support of multiple certification schemes depending to the application. Okay, let me give you an example. Typically, an integrated secure element is by definition very generic in terms of security and can support many different applications. One which is really pushing towards more integration today is the iSIM integration. I mean the SIM authentication on mobile network. So that's one software running on a secure element, on a secure enclave. But you can, of course, execute other software that requires other certification schemes, still using the same basis as hardware and low-level firmware. Okay? It's cost-effective exactly for the same reason, because one hardware can support many different applications, and it reduces the engineering cost for our SoC customers to integrate these elements. We have customers who already have some security expertise, but they rely on us to provide a full subsystem, secure system that is guaranteed for this high-level security certification. Finally, it allows also to provide easy integration of new application, new secure application at a different level. We partner with different OS providers for many different applications. And on top of that, you can integrate other applications, other secure applications. So why an IP secure element with RISC-V, with a RISC-V CPU core? I guess I don't have to convince you about the benefits of the RISC-V architecture, so I will skip that part. But basically, our added value in that is to secure RISC-V processor. So today we have one secure element that is based on a RISC-V core, which is an IBEX 32-bit architecture that is meant targeting embedded software, so with low power constraints. We have a roadmap addressing other RISC-V architecture for more performances, for example. And we are responsible in adding security in this core, countermeasures to resist typically against physical attacks that you have, like side channel attacks, like fault injection, not only on the CPU, but the whole subsystem. The security is not only related to the CPU itself, but also to the peripheral around him. So the communication between the CPU and the crypto accelerator, for example, or also the key management, the interaction with the memories, internal secure memory, but also external flash memories, for example. So we take care of all of that. We take care of certification. We provide boot-ROM code for this whole SoC. We provide certified libraries, software libraries and drivers like cryptographic libraries. And we take care of the lifecycle management in a way that is certified as well. Okay, and of course, thanks to the RISC-V architecture, we can use a modern instruction set and processor architecture. As well, we can benefit from the toolchain and the ecosystem of RISC-V because security software development is no longer something for the specialist only. It's going to be widespread. Every embedded software company now has to integrate security in their ecosystem, in their products. So let me give you one word on our secure element, one description on the secure element. Here you have a very simplified description of the secure hardware on the top and the secure software that we provide on the bottom, and the secure software that you provide on the top. We have, of course, a microcontroller unit, so based on a RISC-V CPU core. We add crypto accelerators. So there are many different crypto accelerators. You have for the symmetric encryption algorithm, like DES and especially AES. You have asymmetric encryption algorithm like RSA and ECC, SHA-2, SHA-3, and the new coming post-quantum algorithm, encryption algorithm that we are currently working on, like many of us, and will deliver also accelerator for these algorithms that are very time-consuming. So our approach for embedded software is to have a reasonable power-consuming CPU, connected to accelerators for the encryption and decryption algorithms that are the ones very consuming a lot of power resources and performances, requiring performances for the algorithm. We also then add security sensors. Security sensor, the list of security sensors varies from the application, but typically for a common criteria L5+ certification, you need to have a temperature sensor, you need to have a glitch detector, voltage variation detectors. You also have an active shield protecting the chip, not the chip actually, the secure element from an intrusion. So we provide all of that, plus of course random number generators, various random number generators, 2 random number generator, quantum technology-based random generator we are working on right now. This is early progress. This is the whole R&D, the whole hardware part of the secure element. On the top of that, you have the low-level drivers and firmware where we provide. We have, of course, compiler and debugger, linker debug chain. This is where on RISC-V we can benefit from this third-party toolchain expertise. We provide the driver for the hardware, drivers for the hardware, as well as the crypto library and various security toolboxes, API, to offer high-level security routines to the application processor, to the SoC, such as secure boot, secure firmware update, over-the-air secure firmware updates, and other secure debug and these kind of facilities. We deliver this IP in 2 ways. The most popular way today is to deliver it as a ARM macro, including the implementation, GDS2. That way it's really a subset of the system. and we can guarantee that it includes all the countermeasures necessary to pass the certification. But we can provide also that as a soft IP. For the hard macro, it has been ported on various geometries from Global Foundry 55 LP down to TSMC 16 nanometer, various processes, and it's customizable. And as I say, target various secure applications. We partner with various OS software providers. That's on our website if you want to know. Okay, and last but not least, it is delivered with this pre-qualified security. Okay, for common criteria L5+ certification or equivalent, like FIPS 140-3. Okay, to conclude, what are the key features of our secure enclave with RISC-V? It's a pre-certified solution. I prefer to say it's a certification-ready solution because the actual object that is going to be certified is our customer chip. Okay? It comes with a complete development kit based on RISC-V environment, both from secure OS developer but as well as for SoC software developers. That includes a secure element inside their chip. It can be delivered as a hard macro or a soft RTL IP macro, as I said, and it can be complemented with key personalization services. Benefit is, of course, scalability for easy integration. It's an off-the-shelf solution. You plug it and play with it, basically, and it doesn't require any security expertise on our customer side. We guarantee a global SoC certification with our help as a service. We reuse actually a lot of the common criteria documentation that is developed for the core for our customer certification. And last but not least, it significantly reduces time to market, but also the risk to get resilient, secured chips, and the risk to pass a common criteria certification. Thank you for your time and your audience.